Electrocardiography is the process of recording the electrical activity of the heart over a period of time using electrodes placed over the skin. These electrodes detect the tiny electrical changes on the skin that arise from the heart muscle's electrophysiologic pattern of depolarizing and repolarizing during each heartbeat. It is very commonly performed to detect any cardiac problems. In a conventional 12-lead ECG, 10 electrodes are placed on the patient's limbs and on the surface of the chest. The overall magnitude of the heart's electrical potential is then measured from 12 different angles and is recorded over a period of time. In this way, the overall magnitude and direction of the heart's electrical depolarization is captured at each moment throughout the cardiac cycle. The graph of voltage versus time produced by this non-invasive medical procedure is an electrocardiogram. There are three main components to an ECG: the P wave, which represents the depolarization of the atria, the QRS complex, which represents the depolarization of the ventricles, and the T wave, which represents the repolarization of the ventricles. It can also be further broken down into the following: O is the origin or datum point preceding the cycle, P is the atrial systole contraction pulse, Q is a downward deflection immediately preceding the ventricular contraction, R is the peak of the ventricular contraction, S is the downward deflection immediately after the ventricular contraction, T is the recovery of the ventricles, U is the successor of the T wave, but it is small and not always observed during each heartbeat. A healthy heart has an orderly progression of depolarization that starts with pacemaker cells in the sinoatrial node, spreads throughout the atrium, passes through the atrioventricular node down into the bundle of His and into the Purkinje fibers, spreading down and to the left throughout the ventricles. This orderly pattern of depolarization gives rise to the characteristic ECG tracing. To the trained clinician, an ECG conveys a large amount of information about the structure of the heart and the function of its electrical conduction system. Among other things, an ECG can be used to measure the rate and rhythm of heartbeats, the size and position of the heart chambers, the presence of any damage to the heart's muscle cells or conduction system, the effects of heart drugs, and the function of implanted pacemakers.